Hello guys, what's up? This is Sir EJ and welcome again to another math tutorial. In today's topic, we will be discussing the introduction to probability. These are the objectives we need to attain in today's topic. At the end of the lesson, the students should be able to letter A, define experiment, outcome, sample space, and event. Letter B, determine the simple and compound events. And letter C, state the formula for finding the probability of simple events. Let us define what is a probability. When we say probability, it is the measure of how likely an event is. Also, it tells us the relative frequency with which we can expect an event to occur. The greater the probability, the more likely the event will occur. It can be written as fraction, or decimal, or ratio. And also, when we say probability, it is the numerical measure of the likelihood that the event will occur. The value of the probability is between the numbers 0 and 1. And when we get the sum of the probabilities of all events, the sum of that probability is equal to 1. And when the value of the probability is equal to 1, that is called certain probability. And if the value of the probability is equal to 0.5, there is a 50-50 chance or 50-50 probability that the event will happen. And if the value of the probability is equal to 0, then the probability of that event to occur is impossible. Let's define some of the terms involving probability. The first one is probability experiment. When we say probability experiment, it is an action through which specific or well-defined results such as counts, measurements, or responses are obtained. Some examples of probability experiment are activities such as rolling a die, tossing a coin, or randomly choosing a ball from a box which could be repeated over and over again. So those are the examples of probability experiment. The next one is the outcome. When we say outcome, it is the result of the probability experiment. And the set of all possible outcomes of a probability experiment is called the sample space. The next term is the event. When we say event, it is a subset of the sample space. Events are often represented by an uppercase letters. Notation: the probability that event E will occur is written as P of E and is read as the probability of event E. Any event which consists of single outcome in the sample space is called an elementary or simple event. So if it has a single outcome, then it is called simple event or elementary event. And events which consist of two or more outcome are called compound events. So we have also the union of events. So when we say union of events, it is an event which is something that has happened and is always associated with an experiment. And we have also the intersection of events, means that all the events are occurring together. Even if one event holds false, all will be false. Now let us proceed with the probability of simple events. If each of the outcomes in a sample space is equally likely to occur, then the probability of an event E, denoted as P of E, is given by the formula probability of event E equals the number of event outcomes all over the total number of possible outcomes in sample space. So this will be the formula when we will get the probability of a simple event. Let's have our first example. A spinner has four equal sectors colored yellow, blue, green, and red. After spinning the spinner, what are the possible outcomes of the experiment? So the experiment here is you are spinning the spinner. So that is the experiment in this probability. And we are looking first for the possible outcomes. Once we have spin the spinner, what are the possible outcomes? So the outcomes will be the four equal sectors, which are the color yellow, blue, green, and red. So those are the possible outcomes of the experiment. Let's answer the next question. What is the probability of landing on each color? Since the spinner has four equal sectors, meaning to say they have the same size or area, then the probability of landing a yellow, a blue, a green, and red can be computed using the formula of the probability of event E equals the number of event outcomes over the total number of possible outcomes in the sample space. So we will be using the formula of the probability of the simple event. All we need to do is to substitute the corresponding value. So we have the probability of E equals the number of event outcomes. Let's say what is the probability that we will get a yellow? So the probability, the outcome, the number of event outcome is equal to 1 because there is only one yellow color. And how about blue? What are the event outcomes of blue? So we have also 1. For green, event outcomes of green, we also have 1. And also red, we have 1 event outcomes because the four colors has 4 equal sectors. And for the total number of possible outcomes in the sample space, we have listed out here the number of possible outcomes, which is equal to 4. So we have 1/4. The probability of landing on each color is equal to 1/4. Let's have our next example. A box contains 3 red balls, 5 yellow balls, and 2 blue balls. If a ball is picked at random from the box, what is the probability that a ball picked is letter A, a color yellow, letter B, a blue ball? So let's find first the probability of picking a yellow ball. To do that, we will be looking for the number of the sample space. The sample space are the set of 3 red balls, and then we have 5 yellow balls, and then we have 2 blue balls. So all in all, the sample space is equal to 10. We have 10 balls with different colors. And then after that, we will be using the formula of simple probability. Probability of event E is equal to the number of event outcomes all over the total number of possible outcomes in the sample space. So bring down P of E is equal to, so we will just substitute the number of event outcomes. So we are looking for the probability that we will pick a yellow ball. So all we need to do is to count the yellow balls that is located in the sample space. So we have 5 yellow balls. So we have 5, which is the number of event outcomes, all over the total number of possible outcomes in sample space, which is equal to 10 because there are 10 balls inside the box. So we have 5 over 10. We will get the lowest term of 5 over 10, and that is equal to 1/2. Therefore, the probability of picking a yellow ball is equal to 1/2. There is a 50-50 chance in picking a yellow ball. Next, using the same problem, this time we are looking for the probability of picking a blue ball. Using the same step, we will identify the sample space. So we have red, 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 5 yellows, and then 2 blue balls, which is equal to 10. So we have 10 balls inside the box. And then we will use the formula of probability. Probability of event E is equal to the number of event outcomes all over the total number of possible outcomes in sample space. So the number of event outcomes, how many blue balls are there inside the box? So we have 2 blue balls. So that is the value of event outcomes. So substitute it with our formula. So the number of event outcomes will be equal to 2 all over the total number of possible outcomes in the sample space, which is equal to 10 because there are 10 balls inside the box. So we have 2 over 10. We will get the lowest term of 2 over 10, which is equal to 1 over 5. So the probability of picking a blue ball is equal to 1 over 5. Let's try to answer the following sets of questions on the next slide. Question number 1. Which of the following is an experiment? Letter A, tossing a coin. Letter B, rolling a single six-sided die. Letter C, choosing a marble from a jar. Or letter D, all of the above. Alright, very good. The correct answer is all of the above. Next question. Number 2, which of the following is an outcome? Letter A, rolling a pair of dice. Letter B, landing on red. Letter C, choosing 2 marbles from a jar. Or letter D, none of the above. Alright, very good. The correct answer is landing on red. Question number 3. Which of the following experiment does not have equally likely outcomes? Letter A, choosing a number at random from 1 to 7. Letter B, tossing a coin. Letter C, choose a letter at random from the word school. Or letter D, none of the above. That is great. The correct answer is choose a letter at random from the word school. Question number 4. What is the probability of choosing a vowel from the alphabet? Letter A, 21 over 26. Letter B, 5 over 26. Letter C, 1 over 21. Or letter D, none of the above. Alright, very good. The correct answer is 5 over 26. We have 5 vowels in the alphabet, which is A, E, I, O, U. So those are the 5 vowels over 26 because we have 26 letters in the alphabet. So the answer is 5 over 26. Last number, question number 5. A number from 1 to 11 is chosen at random. What is the probability of choosing an odd number? Letter A, 1 over 11. Letter B, 5 over 11. Letter C, 6 over 11. Or letter D, none of the above. Alright, very good. The correct answer is 6 over 11. We have 6 odd numbers on the numbers 1 to 11. So we have 1, 3, 5, 7, 9, and 11. So those are the 6 odd numbers all over the total number of sample space, which is equal to 11 because we have 11 numbers from 1 to 11. Therefore, the probability of choosing an odd number is equal to 6 over 11. Alright, let's answer some more. Suppose we have a probability experiment. A single six-sided die is rolled. Let's answer the following questions. What is the probability of each outcome? Letter B, what is the probability of rolling an even number? And letter C, what is the probability of rolling an odd number? Let's identify first the possible outcomes of the sample space. So we have 1, 2, 3, 4, 5, and 6 as the possible outcomes of the experiment, or this is the sample space. We will be using the formula of simple probability. Probability of event E equals to the number of event outcomes over the total number of possible outcomes in the sample space. Let's answer first letter E. What is the probability of each outcome? So we will get the number of event outcomes. The number of event outcomes is equal to 1 because 1 will only occur one time, 2 will occur one time. The numbers 3, 4, 5, and 6 will also occur one time. So the number of event outcomes is just equal to 1. All over the total number of possible outcomes in the sample space, so we have 6 numbers in a die, so that is 6. So the probability of rolling a die for each outcome is equal to 1 over 6. Letter B, what is the probability of rolling an even number? So what are the even numbers from the numbers 1 to 6? So we have 2, 4, 6. So we have 3 number of event outcomes all over the total number of possible outcomes in the sample space, which is equal to 6. So lowest term of 3 over 6 is equal to 1/2. And then for letter C, what is the probability of rolling an odd number? What are the odd numbers? Can be found from numbers 1 to 6. So we have 1, 3, and 5. So we have 3 over 6 again. The total number of possible outcomes in the sample space is equal to 6. And then if we will get the lowest term again, this is equal to 1/2. So the probability of getting or rolling an odd number in a die is equal to 1/2. Let's have our last example. Choose a number at random from numbers 1 to 5. Letter A, what is the probability of each outcome? Letter B, what is the probability that the number chosen is an even number? And letter C, what is the probability that the number chosen is an odd number? Let's identify first the number of possible outcomes of the experiment. So we have 5 numbers, which is 1, 2, 3, 4, and 5. So the number of possible outcomes in the experiment is equal to 5. And then we will be using the formula of simple probability. Probability of event E equals to the number of event outcomes all over the total number of possible outcomes in the sample space. Let's compute first for the probability of each outcome. Since the numbers 1, 2, 3, 4, and 5 will only occur once, they will be equally likely to occur on the experiment. So the number of event outcomes will be equal to 1. All over the total number of possible outcomes in the sample space is equal to 5. So the probability of each outcome is equal to 1 over 5. And then for letter B, what is the probability that the number chosen is an even number? So we will count the even numbers. So the numbers that is even is 2 and 4. So we have 2 even numbers all over the sample space, which is equal to 5. So the probability of choosing an even number is equal to 2 over 5. And then for the last one, what is the probability that the number chosen is add, we will count the event outcomes, which is the number of add numbers. So we have 1, 3, and 5. So we have 3 add numbers. So we have 3 over the possible outcomes in the sample space, which is equal to 5. Therefore, the probability of choosing an odd number is 3 over 5.